Nice. I always do this where I don't pull up the stream so I can see the chat. Not that anyone is going to be watching, but I do like to see the chat just in case. Okay, nice. Okay, there. I can see it now. Hopefully. Ooh, it's gonna fall. Sorry, I should like set up way before I start. This is a little bit embarrassing. Okay. Nice. I should also note on my Discord that I'm streaming. Uh, okay. Hi everyone. So yesterday we had a little hiccup with Lumi where I should like sorry I keep doing this thing where I okay, so in yesterday's stream, or I guess if you're watching this on YouTube, it's like the same video because I'm gonna put both streams together in one video. And yeah, anyway, if you were here yesterday, which I know no one was, but like, humor me for a second. If you were here yesterday, you saw that Lumi was having some trouble with the homework upload feature, specifically around diagrams. Uh, and I spent all day today trying to figure out why that was. And I think I got it. I think it was working earlier today, so we'll see. But yeah, we're gonna do what we've been doing the last couple of streams. I'm just gonna stream myself doing a bunch of questions. Today I want to do something a little bit different. I'm going to stream myself solving some algebra regions problems. I just said algebra regions, geometry regions problems. Uh, and we're going to see if Lumi can draw diagrams and be able to keep track of the board state. It seemed like it was Lumi wasn't able to tell that the whiteboard had gone away or that I had closed the whiteboard after she had drawn something, or I should say he because I have it as a he voice. Uh, but we'll see today. We'll see today. So just gonna jump right into it because I'm gonna be streaming for a little bit today. I want to stream for maybe a little bit over an hour if I can. That'll give me a lot of content to put up on YouTube and TikTok. But we'll see. I also want to make a short with the parent dashboard, so I'll record that towards the end and stitch it together. Uh, I'm sorry. I keep looking down. I know I say this all the time, but I keep looking down because my stream is there. Okay. So we're gonna start with the geometry regions. That's not the regions. This is the regions. That's not the question I wanted to do. I had them all loaded. I swear. I swear. So the question that I wanted to tackle is this one. So we can see here. Right. I'm gonna be completely honest. I don't know how to do this. I was looking at this and I just was like, I don't really remember any of this. So I think this is the perfect question because I don't know how to solve it, and Lumi can hopefully walk me through it. So just like before, gonna go to help with my work, and just gonna upload that screenshot I took. Oh no, something went wrong. What went wrong? What did I mess something up? I think it's because I didn't refresh. So let me just refresh. Okay, help with my work. Upload this. It was working earlier today. I'm okay now. I'm like really scared because I'm just not gonna say anything. I'm just gonna stand here and wait for Lumi to be ready. This is making me so nervous. Anyway, let's talk updates. So yesterday I also mentioned that I want to take the GREs. You can see actually on the left side there that I started my GRE prep. Um, but I need to take a diagnostic first. I want to do sort of a before and after to show that Lumi can help someone pass any of these tests. Uh, I want students to use it for tests like the Regents or the SHSAT, and that's because I live in New York, so I don't really know what other tests exist outside of those two. Uh, but obviously there's the SATs that everyone takes, the PSATs. I know students in other states. There are many state standardized tests. So I just want to show that Lumi can prepare you for any test you have coming up, as long as you can define what that test is. Now, again, the last time I took the GRE, I think was 10 years ago, and I did not do well. I think I was well below the 50 percentile in everything really, which I guess maybe I shouldn't admit to on stream, but like it's fine. It's fine. I'm much better at math now. I am with all the teaching experience I've had. Okay, Lumi is ready. So uh, let's just start. Unavailable. Oh, I know why this is. I know why. I forgot to reset my minutes, and I'm like way over the minutes. Okay. Uh, I need to pause the stream for this. Can I do this? I can do that. Okay, okay. 1 second, 1 second. I'm just gonna reset my minutes so I can actually talk to Lumi. And it looks like I have 45, so that's fine. Okay, I'm resetting my minutes because I completely forgot. I completely forgot to do that earlier. It helped me to fix an issue. Uh okay. So here, okay. I should actually just give my account unlimited minutes. I don't know why I don't do that. Uh I'm actually so glad no one is watching because oh man, this would be so bad if someone was actually in the stream right now. Or if I had viewers. If I had viewers, that would be really bad. So okay. Okay. My bad, my bad. I'm doing it. I'm doing it. It's gonna take a second. Need to connect to my database, and I forgot where the columns were, so I need to figure out the columns. I'm searching for them now. Okay. Uh, it's usage tracking. It's usage tracking. Okay. This doesn't count for the stream though, so I'm gonna be streaming a little bit extra late tonight, which is fine. I'm not too mad about that actually. Oh, wait. No, no, no. Hold on. Sorry. I will. It will be fixed. Give me 1 second. Okay. That should have fixed my voice minutes. Yes. Okay. I can turn the stream back on. Okay. Hello, everyone. Welcome back. Okay. So, like I was saying, we're going to upload this. Sorry about that. Sorry about that. I forgot to fix my voice minutes. But I'm back. I have 45 minutes available, so I guess I can stream for the 45 minutes, and then I'll probably just reset it again and stream for another, maybe another 45. But that's a lot. I shouldn't stream that much. I'll stream for the first 45 minutes. We'll do all these problems. We'll do a couple more from Reddit. You see Reddit I have open up there, and then I'll call it a night. That'll be the end of the stream as soon as this loads. Uh, I need to stop saying. I realized as I stream that I say way too much, or I like put fillers. So I'm gonna try to really catch myself and not put fillers in my speech. It makes editing the videos so much harder when I use filler speak. Uh, oh, I just did it again. See, I need to. I'm gonna try to catch myself doing that. So just waiting for Lumi to analyze the work, get the problem text, and then hopefully draw the lines correctly. And I'm sorry that I keep looking down. I need to like find a way to have a dual monitor setup where one side is the stream here and the other side is the actual the content. Okay, here we go.
Hey, Jin! Welcome back! I can see you've uploaded a geometry proof problem about proving quadrilateral ABCD is a parallelogram. The diagram shows the quadrilateral with that extension through D to point E and those intersecting segments at F. What part of this proof are you finding tricky? Or would you like me to help you work through the whole thing step by step?
Hey Lumi, I actually don't remember how to do any of this, so step by step would be great. But first, can you draw it on the whiteboard so we can see it?
No worries, Jim. Geometry proofs can feel rusty if you haven't done them in a while. Let me recreate this diagram on the whiteboard so we can work through it together visually. Perfect. Here's the diagram. The quadrilateral ABCD is shown in black, with the extension from D to E in blue dashed line. The two red lines are AD and BE, which intersect at point F. Now, let's start working through this proof. What information are we given in the problem?
Actually, Lumi, I'm using dark mode and I can't really see the black lines. Can you make the lines white so I can see them a little better? Also, point F isn't at the exact intersection. Can you fix that, or is that just not a thing you can fix?
Good catch on both. Let me clear this and redraw it with better visibility and fix point F's position. The coordinates from the vision system should put F at the actual intersection. Let me recalculate that precisely. Much better. Now you can see everything clearly in dark mode. The quadrilateral ABCD is in white. The extension to E is the cyan dashed line. And the two intersecting segments, AD and BE, are in yellow with F at their intersection. Now let's tackle this proof. What information does the problem give us to start with?
So you can see that Lumi, I asked to recreate it, and Lumi did a really good job. It's not pixel perfect, but I think that's just a limitation of large language models right now. As the technology improves, Lumi's ability to draw will get way better. Sorry, Lumi, I'm actually talking to the stream. So, I can't see the problem because of the whiteboard. Can you tell me the problem again, and then I'll try to fill in what I need to?
No worries, Jin. And thanks for the feedback. You're right that the spatial reasoning will keep improving as the tech evolves. Here's the problem. In quadrilateral ABCD, side CD is extended through D to point E, such that segments AD and BE bisect each other at point F, and DE equals DC. Prove that ABCD is a parallelogram. So the key given information is 1. AD and BE bisect each other at F. 2. DE equals DC. Now, what do you think would be a good first step to start this proof?
Well, I'm just gonna mark the DE and E. Sorry, yeah, the DE and DC are equal in length. But I think that a really good starting point, since we know they bisect each other, doesn't that mean that that angle in the middle where F is, aren't all of those 90 degrees?
Ah, interesting thought. But actually, bisect each other doesn't mean they cross at 90 degrees. That would be perpendicular bisectors. When we say two segments bisect each other, it means they cut each other exactly in half at their intersection point. So what does that tell us about the distances?
Okay,
Like,
okay.
what?
I see now. Oh, sorry, I didn't mean to cut you off. You were still talking. But what that means is that EF is equal to FB and AF is equal to FD.
Perfect. You've got it exactly right. EF equals FB and AF equals FD. So, F is the midpoint of both segments. Now here's a key question. If you look at points A, B, D, and E, they form a quadrilateral. What theorem do you remember about quadrilaterals whose diagonals bisect each other?
Oh, there's a theorem for that? I don't know. I don't know. I don't remember.
No worries. This is a key theorem that makes this proof work. Here's the big idea. If a quadrilateral has diagonals that bisect each other, then that quadrilateral is a parallelogram. It goes both ways too. A quadrilateral is a parallelogram if and only if its diagonals bisect each other. So looking at quadrilateral ABDE, its diagonals AD and BE bisect each other at F. What does that mean ABDE must be?
don't you mean ABCD? What do you mean ABDE? Oh, am I supposed to draw like missing lines there to make it a quadrilateral?
Exactly. Great insight. Yes, you need to imagine connecting A to B, B to E to D, and D back to A. Let me draw that on the whiteboard so you can see it clearly. See the green line I just added? That completes quadrilateral ABDE. The sides are AB, BD, DE, and AE. The yellow lines AD and BE are the diagonals of this quadrilateral ABDE, and they bisect each other at F. So now, what type of quadrilateral must ABDE be?
Oh, okay. So then ABDE, this quadrilateral here, is a parallelogram? No. It's a. You just told me. You just told me. Sorry. It's a parallelogram, right?
Yes, exactly right. ABDE is a parallelogram because its diagonals bisect each other. Now, here's where it gets clever.
Wait, sorry.
Since A
Before you do that, can you draw the line from B to D so I can see it there too? Because I drew it, but I don't see it on the whiteboard, and it's kind of confusing me.
Of course. Let me add that BD line to complete the quadrilateral ABDE more clearly. Perfect. Now you can see the complete quadrilateral ABDE with all four sides. The green lines AB, BD, DE, and EA form the parallelogram ABDE. Now, since ABDE is a parallelogram, what do we know about its opposite sides?
Oh, yeah. Parallelograms, the opposite angles are congruent. Or do you mean sides? Because then if it's sides, the opposite sides are parallel.
Perfect. Yes, I meant sides. Opposite sides are parallel, and they're also equal in length. So, in parallelogram ABDE, which sides are opposite to each other?
So then AB is equal to ED, and EA is equal to BD.
Almost. AB is equal to ED. You got that part right. But for the other pair, think about which side is across from BD in the parallelogram ABDE. Which side would that be?
It's AE.
Exactly. So we have AB equals DE and AE equals BD. Now here's the clever part. We also know from the problem that DE equals DC, right? So if AB equals DE and DE equals DC, what can we say about AB and DC?
Oh, okay. So AB and DC are also equal.
Yes, perfect. So AB equals DC. Now we also said that AB is parallel to DE because they're opposite sides of parallelogram ABDE. Look at the diagram. Notice that ED and C all lie on the same straight line. If AB is parallel to DE and D and C are on the same line with E, what does that tell us about AB and DC?
Oh, that must mean that AB and DC are also parallel.
Brilliant! You've got it! So now, looking at quadrilateral ABCD, we've just shown that AB is parallel to DC and AB equals DC. If one pair of opposite sides in a quadrilateral is both parallel and equal in length, what does that make the quadrilateral?
It makes it a parallelogram?
Yes, exactly right. And that's what we needed to prove. You sound a bit uncertain, but your answer is 100% correct. That theorem says if a quadrilateral has one pair of opposite sides that are both parallel and equal in length, then it's a parallelogram. We just showed ABCD has exactly that. AB is parallel to DC, and AB equals DC. So ABCD is a parallelogram, and we're done. Does the whole proof make sense now when you look back at it?
Yes, I'll actually need to write out the proof statements though. So, I know, okay, I don't want to cheat, but can we go through the statements that I would need to make at each line? And then I'll come up with the reason later, but I do want to write out the statements at least.
Perfect. I love that approach. Let me help you outline the key statements. Let me write them on the whiteboard for you. There you go. These are the 5 key statements you need. For each one, you'll need to provide the reason, like given or name the theorem. Does this outline capture what you need to write in your proof?
This proof is only 5 steps. I feel like we talked for 20 minutes, but all right, yes. I do understand that actually makes a lot of sense. To prove something is a parallelogram, you really just need to prove that two of its sides are parallel and the same length. Once you prove that, it's a parallelogram.
Exactly. That's the beauty of it. Once you understand the logic, the proof is actually quite elegant and compact. The 20 minutes we spent was all about building that understanding, figuring out what quadrilateral ABDE was, why it mattered, and how it connected to ABCD. Now you've got the core insight. One pair of opposite sides being both parallel and equal is enough to guarantee a parallelogram. That's a powerful theorem. Do you feel ready to write this up with the reasons now?
Yes, and also we can move on to the next one. So I'm gonna upload the next problem now, and we'll work on that one.
Perfect. I love the determination. You're on a roll. Let me clear the whiteboard and get ready for your next problem. Go ahead and upload it whenever you're ready. All set. Upload the next
Okay, I didn't know Lumi was gonna just clear the whiteboard like that. That's great. Okay, so first problem down. Actually, that's actually really cool. I didn't even see this, and I didn't see this, and I didn't know that you can prove. Uh, I didn't know you can prove it that way. That was really cool. I really like. I actually genuinely enjoyed doing that. Okay, let's do the next problem. So that's this one down. We're gonna do this. It reset all my pro. Okay, I didn't want to do the last one here. Uh, there was one that I saw and I was like, I want to do this one. Where is it? Where is it? Oh, it's this. It's this. No, I feel like it was that actually. It's this triangle one. So triangles are a big part of geometry. A lot of students struggle with them. So I want to show that Lumi can solve a triangle problem. Okay. So here we go. New one. Oh, it's this one. Okay. I should probably also, well, you know what? While this is going on, I'm gonna draw the triangle because, like, I should just draw it. I also saw that I was drawing them kind of small, so I'm gonna make these a little bit bigger. And also, why did I start here? Why did I start here? I should have started here. Look, I started in the center, and now I can't. Like, I don't feel like I can use any of these. Why did I do this? I don't know. Anyway, triangles. Let's see. So we have this triangle. Is this what it looks like? Bro, that's not even. That's not even. I'm just gonna. You know what? It is what it is. It is what it is. It's TAN. So TAN, and then we have MEL. 5.646, and then 8.469. 8.4, 8.469. And then Explain why ant is similar to elm. Explain ant similar to elm. Okay. Uh, yeah, I don't know. I don't know. I know some stuff about triangle similarity. Uh, but I don't know everything, so we'll see. We'll see. Let's see what happens. Uh, hey, Lumi.
Hey Jin,
Oh,
welcome back. I see you've uploaded a similar triangles problem. Problem 31, with triangles ANT and ELM. You've got all the side links listed out. What part of explaining why these triangles are similar would you like help with? Or should we work through the whole explanation together?
yes, can we work through the whole explanation together? And can you draw the triangles first before we start?
Absolutely. Love the energy. Let's dive in. Let me draw both triangles for you, with all the side lengths labeled. Perfect. Here are both triangles, with all their side lengths. Triangle ANT is in cyan on the left, and triangle ELM is in yellow on the right. Now, to prove these triangles are similar, what do you remember about the ways we can show two triangles are similar?
Okay, so I just want to take a moment and say that Lumi drew these diagrams near perfectly. Maybe the size of the triangles isn't exactly the same as in the problem, but oh my gosh, look at the lines. The points are perfect. The labels are perfect. The lengths, in my opinion, look perfect. Thank you, Lumi. What I remember from triangle similarity is we just need to prove angle, 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 right?
Thank you so much, Jin. That really means a lot. I'm glad the visual representation is working well for you. The computer vision system is definitely improving. So, angle A angle is absolutely one way to prove similarity. You only need two angles, actually. But here's the thing. In this problem, we're not given any angle measurements. Look at what information we do have, just the side lengths. AN equals 6, NT equals 5.6, TA equals 4, and EL equals 9, LM equals 8.4, ME equals 6. So what's another way to prove triangles are similar when you only have side information?
Wait, we can't use sine, cosine, tangent here to prove to find two of the angles and just show that they're the exact same? That's what I was thinking.
That's creative thinking, Jin. You absolutely use law of cosines to find angles and then prove AA similarity. That would technically work. But that's a lot of calculation, and geometry proofs usually look for the most elegant approach. Here's a hint. There's a similarity theorem that works directly with sides, no angles needed. It's called SSS, similarity, side, side, side. What do you think that theorem says about how the sides need to relate to each other?
Oh, okay, you know what? I'm actually now that you said that, yeah, I was that would have been a lot of calculation. I think that what we really just need to show is that the ratio of the sides are all the same. So like 4 divided by 6, 6 divided by 9, and 5.6 divided by 8.4.
Exactly. You've got the right idea. We need to show that all three pairs of corresponding sides have the same ratio. Let me write out those calculations on the whiteboard so we can check if they all equal the same value. Perfect. I've written out the three ratios you mentioned. Now let's simplify each one to see if they're all equal. Can you simplify 4, 6 first? What does that reduce to?
Oh yeah, that's just 2/3.
Perfect. Now what about 6 nines? Does that also simplify to 2 nines?
Do you mean 2/3? And the answer is yes. It does also simplify to 2/3.
Exactly. Now here's the tricky one. What about 5.6 divided by 8.4? Can you simplify that or calculate what it equals?
Yeah, I'm not gonna hold you here. I genuinely have no idea. But if we divide 5.6 by 2, right, we're gonna get 2.4 something, and then we divide 8.4 by that number to see if we get 3.
That's a good approach. But here's a cleaner trick. Notice that both 5.6 and 8.4 are decimals. What if we multiply both the numerator and denominator by 10 to get rid of the decimals? That would give us 56 over 84. Can you simplify that fraction?
Oh, yeah, yeah, wait. No, that's so much better. Yeah, yeah. So we can divide those both by 2 and we'll get 26 over 42, and we divide them by 2 again and we get 13 over 21, uh and then 13 over 21. Wait, did I divide wrong? I feel like I divided wrong.
Let me write out your steps to check. You said 56 divided by 2 equals 26. But let me verify. What's 56 divided by 2?
It's not 26. Oh my gosh. It's 20, it's 28. It's 28. It's 20. I said 28. I didn't say, no, I didn't say 28, but it's 28.
Perfect. You caught it. 56 divided by 2 equals 28, and 84 divided by 2 equals 42. So we get 28 divided by 42. Now can you simplify 28 divided by 42? What number divides evenly into both?
Uh I do this really stupid thing where I just keep dividing by 2 until I can't, and then I start dividing by 3. So from 28 over 42, we get 14 over 21, and then 7 goes into both of those. So it becomes 2/3.
That's not stupid at all. That's a perfectly systematic approach. And you're absolutely right. It equals 2/3. So look what we've discovered. All three ratios equal 2/3. What does that tell us about triangles ANT and ELM?
That means that they're similar. They have to be similar triangles.
Exactly. And specifically, what similarity theorem did we use? What's the name when all three pairs of corresponding sides are proportional?
Well, I mean, you wrote it on the board, so I guess it's SSS, but that means side, 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 which you also told me earlier, so I didn't know it, but thank you for telling me.
Ha! Fair point. I jumped ahead and wrote it. But honestly, you figured out the hard part. You discovered that all the ratios were equal to 2/3, which is the key insight. The theorem name is just a label we put on it. So when you write your explanation, you'd say triangle ANT is similar to triangle ELM because all corresponding sides are proportional with a ratio of 2/3, which satisfies the SSS similarity theorem. Does that make sense as your complete explanation?
Yes, 100%. Thank you so much. And I just want to say that this whiteboard, like it's picture perfect. Like I want to take a picture of this and save it because wow, this looks beautiful. I love all the work. The decimals look weird in the fraction, and I guess maybe I can tweak that. But other than that, love it. I'm gonna upload the next problem now.
Thank you so much, Jin. That really makes my day. I'm glad the visual layout worked well for you. Yeah, the 5.6 and 8.4 in the fraction do look a bit funky. Definitely something to note for improving the rendering. Before you upload the next one, does everything make sense about this problem?
Yes, everything made sense. Thank you.
Perfect! Go ahead and upload the next problem whenever you're ready. I'm here to help.
Nice. Okay, so we're gonna do the next one now, and yeah, this that worked so well. I really like that. I know I'm not really saying there's no one in the stream to see it, which is man, I'm so sad that no one is here to see it because that was so cool. But it's fine. It's fine. Whatever. I'm gonna do this one now. So last geometry pro- last geometry proof. Again, just doing some geometry proofs today because I don't really know them. A couple of my students are taking geometry, so this is actually kind of nice for me. I get to sort of do a little bit of warm up before I see them this week. Uh, but here we go. Here we go. I really did like the whiteboard in that problem. I feel like it worked really well. Uh, I'm genuinely excited to edit this video. I want to get a clip of me saying something. Uh, I was a teacher for like 8 years, and then I was a private tutor for 3 years. So I'm really good at math. Okay, I just wanted to say that because I'm gonna use that clip in a couple parts of the video. Like I'll rearrange it, and now I'm gonna say that in the beginning. Uh, and then it's good, like okay, okay. Anyway, Lumi's ready. Let's see.
Hey Jin, welcome back. I see you've uploaded problem 34, a geometry proof about triangle ACD with that parallel line BE. This looks like a similar triangles proof situation. Before we dive in, how are you feeling about this one? Do you want me to recreate the diagram on the whiteboard first so we can visualize it together? Or would you like to talk through the strategy first?
Yeah. Can you recreate the diagram?
Absolutely. Let me recreate the diagram for you, with all the points in lines labeled clearly.
It seems to have gotten stuck. Is everything? Are you able to draw it? Did something happen?
Oh no, you're right. I opened the whiteboard but didn't actually draw anything. Let me draw all the elements now. Here we go.
Wait, sorry. I actually I can't see the lines or the points because I'm in dark mode and you drew everything in black. Can you draw everything in white or a different color just so I can see it?
Oh, shoot, you're absolutely right. That's a great catch. I should never default to black in drawings, since it won't work in dark mode. Let me clear this and redraw everything in colors that will show up. Perfect. Now you should be able to see everything clearly. Triangle ACD is in cyan, and the parallel line BE is in yellow. Can you see it all now?
Yeah, I can see it all now. So as you can see, it seems like the issue might be drawing points on lines and intersections, but still a very close drawing. Okay, Lumi, I'm ready. If you can take me through the entire problem, please.
Perfect. Thanks for the feedback on the points. That's super helpful for improving the rendering. Alright, let's dive in. So we need to prove that AB times AD equals AE times AC. Looking at this diagram, what do you notice about the setup? We have triangle ACD with this line BE that's parallel to the base CD. What does that parallel line situation remind you of in terms of triangles?
I know it means something. I know that it does, but I really don't know what it means.
That's totally fair. Let me help you see it. When you have a line drawn parallel to one side of a triangle, it creates a smaller triangle inside that similar to the big one. Look at the diagram. Can you identify two triangles here? One is the big triangle ACD. What's the other smaller triangle that BE helps create?
Okay, I mean that's so obvious. I can't believe I didn't even guess that. But yeah, it's ABE. That's the other triangle.
Exactly. Triangle ABE is the smaller one inside. Now here's the key question. You just worked on similar triangles in the last problem, right? So how can we prove that triangle ABE is similar to triangle ACD? What do you remember about proving similarity?
Wait, no, you're so right. So what that means, so because this creates a parallel side, it means sorry, because that line is parallel to one side, these triangles are similar, right? Like we can just say that. That means that the ratio of the sides are all the same. So like AB has the same AB divided by AC is the same as AE divided by AD.
Yes, you absolutely nailed it. That's the key insight right there. Let me write that proportion down.
Yes, I see it. Did you get stuck? It says that you're loading.
I'm here. Not stuck, just wrote that proportion on the whiteboard. Now here's the beautiful part. Look at what we need to prove. AB.AD equals AE.C. And look at what we have. AB divided by AC equals AE divided by AD. What operation could we do to this proportion to get the equation we need?
Yeah, this one is so easy. These questions are this easy? Okay, obviously. Okay, well, I guess they're just testing if you know the subject. So obviously, all we do is cross multiply here, and we get our solution. We prove that they're equal.
Exactly, you crushed it. Let me show the cross multiplication. Perfect. And that's exactly what we needed to prove. You totally nailed the key insight. Once you recognized the similar triangles and set up the proportion, the cross multiplication was straightforward. The elegant part is how that parallel line creates the similarity in the first place. Does the whole proof make sense now?
Yeah, and I guess to be fair, I didn't even know that, so I would have gotten this question wrong. Because there's no way I wouldn't have just been able to guess that. So yeah, it is a good test because it's testing if you even know if you understand it well enough to be able to recognize the situation that it's in.
That's such a great observation, Jin. You're absolutely right. The hard part isn't the algebra at the end, it's recognizing the pattern. That's what separates understanding from just memorizing formulas. Now you know, when you see a line parallel to one side of a triangle, think similar triangles. Does everything make sense? Or any questions before we move on?
Yeah, I guess I know that now, but like we'll see if I remember that, a year from now when a new student comes to me and is like, "Hey, I need help with this triangle problem."
Ha! Fair point. Teaching is the best way to remember, though, so you'll probably retain it better than you think. Plus, you've got this platform now, so you can always look up similar problems. Ready to tackle the next one? Or want to take a break?
Wow, you're asking me to take a break. That's actually really good. Do you know how long we've been going for the stream? Like how long has it been that we've worked on these three problems?
I don't have access to the actual timestamp info, but based on our conversation flow, I'd guess we've been at this for maybe 10 to 15 minutes. Geometry proofs can be deceptively time consuming because there's so much conceptual thinking involved. How long does it feel like to you?
Uh, it's actually been a good. It's been about 40 minutes that we've been working actually.
Wow, 40 minutes! That's actually solid focused work time. Three geometry proofs with all the discussion, diagram recreation, and conceptual understanding. You're definitely putting in quality learning time, not just rushing through. How are you feeling? Want to power through more, or is a quick stretch break calling your name?
I actually just checked. It's actually been 50 minutes, and I guess we've been talking for a couple minutes, so maybe 48 minutes. But no, I think I'm actually gonna end the stream now. Been about an hour. That's a good amount of content for me to have to edit tomorrow. Uh, but yeah, thank you for going through these problems with me. I actually did learn a lot today. We didn't get to do the Reddit problems like we did last time, but these were good. These were good.
That's awesome, Jin. I'm really glad we could work through these together. You crushed those similar triangles proofs once you saw the patterns. Good luck with the editing tomorrow, and I hope the stream content turns out great. The diagram recreation feedback was super helpful too. Come back anytime you need help, whether it's more geometry or those red challenge problems. Have a great rest of your day.
Okay, so I intended to go a little bit longer, but I think an hour is good, given that I don't have any viewers, and man, it's so soul crushing to be here and not have any viewers because I like. Oh, okay, but it's fine because I'm actually genuinely enjoying it. I love working with Lumi. It's actually a lot of fun. I hope that I can inspire kids to want to interact with Lumi and do work in the same way. I use the help with my work feature all the time. I will do the other stuff as well. Like I'll show the other features. I've been having so much fun with this. I haven't been able to, or I haven't. I should just say I'm being lazy about it. But thank you anyone who stopped by. I don't. It seems like no one stopped by, but it's fine. Oh, I'm so sad. Okay. All right. Yeah, I will be back tomorrow. Same thing. Going to be streaming some problems either in a Regents test or on Reddit, and we'll see if I can understand it. If Lumi can help teach it to me. Okay, thank you everyone. I will see you in the next one. Oh, I wanted to record the parent message. Okay, let me Let me sign out. No, let me just be on my learning journey. It needs to be like a short that I record. Are you a parent whose child struggles in math? No, that sounds so. Why does that sound so television advertising? Oh my gosh. Hey everyone. No. Uh, do you ever wish you had a way to? No, that's so bad. I don't know how to say it. Uh, hey, I'm Jin, and I built this tool to help parents get an insight into their child's learning journey and education. Nope, that was bad too. Uh, I will think of the script for this, and I will write it tomorrow, and then I will film it tomorrow. Okay, bye everyone. Thanks for stopping by.